Here's a wrinkle. Suddenly there's trig in our calculus. They tell us that our original function is sine x. Now, the order in which we do the units in this course, we have not talked about trig derivatives yet, or we may not have. If you have not seen this yet, you are going to be stuck unless you know a critical fact that the derivative of sine x is cosine x. I'll give you that for free so that we can get through this problem. When your function is f of x, your derivative is cosine x. If you haven't seen that yet, you will in a few weeks, but we'll just trust me on this for now so that we can carry on with the Newton's method stuff. So we have our function, we have our derivative, we have an initial guess, x1 equals 3, and now our next guess is given by previous guess minus f of our original guess, which means sine 3. Now make sure you're in radian mode when you do this. We don't mean 3 degrees, we mean 3 rads. The sine of 3, if you do it right, should come out to 0.141120. And the derivative of it would be cosine 3, again in radian mode, and that comes out to negative 0.989992 for a final value of, the negatives cancel, we'll just lose those, so 3 plus 0.141120 divided by 0.98992. 3.1425466. Well, I've only been going to 6 decimal places, so let's trim that off at 547. Okay, so first guess, second guess. By the way, what's the solution for this? When is sine equal to 0? Do you know it? There are a few places. One of them is 0. The next one is pi. And look at that. This thing went straight from 3 to 3.14. It seems like it's trying to lock on to pi, and it's only got the first couple decimal places, but let's see if it does any better in the next step. It seems like it's going to try to. It may bounce around a bit, but it should converge towards pi if we keep working. So for our next step, 3.142547 minus, we take this number and put it into our function, which means we sine it. So we have to put 3.142547 sine, make sure you're still in radian mode, and that comes out to minus 0.000954. And then we do the cosine of that, 3.142547, and radian mode and cosine, negative 0.99999. You know what? Looking at this now, I've got my 7th decimal place. Here's what I get on my calculator display. If I round this to 6 decimal places, it comes out to just negative 1.000000. So that's nice. That's one less step to do. 2 of these negative signs cancel. And so we get 3.142547 minus this amount. And it's divided by 1, which I'm just going to ignore. So 3.142547 minus 0.000954. 3.1411593. Now pi is really 3.1415926535897 blah blah blah. So after just a couple iterations, this thing it's a perfect match to 5 decimal places, and the 6th decimal place is a rounded version of pi already. So if we carried more decimal places going forward, we could get this to even closer to pi, and it'll get more close to pi every time we do another iteration.